We're going to talk about derivatives of trig functions. But before we do derivatives of trig functions, we're going to kind of go back to limits of trig functions, get a little review of that. Remember from first chapter, limit as theta approaches 0 of sine of theta over theta is just going to be 1. Right, and should have written this in here, but the reciprocal of that, limit as theta approaches 0 of theta over sine of theta, is also 1. So those are two we should be familiar with from last chapter. This one we didn't really use last chapter, but the limit as theta approaches 0 of 1 minus cosine of theta over theta, well, if we use direct substitution, that would give us 0 over 0, because cosine of 0 is 1. But just like this, we can find this limit just using a different technique. We're not going to go through how to find it. We just need to remember that the limit of that is going to be 0. All right, so limit of 1 minus cosine of theta over theta as theta approaches 0 is going to be 0. So these are ones to remember and that we're going to use for these limits down here. So number 1 is kind of like ones that we saw last chapter. This is where we split these up. The limit as x approaches 0 of sine of 4x times 1 over 2x. We're trying to split it up and then make the limits, or the parts that have the sign, look like this, either sine of theta over theta or theta over sine of theta. So in this case, we need a 4x in the denominator. So I'm going to multiply the bottom by 4x so that this matches our limit up here. But if we do that, we have to balance things out and multiply the top by 4x. So I'm going to do that right here where the 2x is. I'm going to actually multiply the top by 4x up here. And still multiplying the numerator, just kind of positioning it where it's going to be helpful for us. All right, the x's here cancel out, and now we can do the limit of each part individually. So the limit as x approaches 0 of sine of 4x over 4x, that's just going to be 1, times the limit as x approaches 0 of 4 over 2, or just 2. Remember, limit of a constant is just that constant. So we end up with an answer of 2 for this one. All right, number 2, a little bit different. We have a tangent in there, so we want to rewrite this so that we're dealing with sines and cosines instead of tangents. And tangent is the same as sine of x over cosine of x, and that's all over 2x. We want to go ahead and split things up, but first let's get rid of the fraction and a fraction. We can write this as limit as x approaches 0 of sine of x over cosine of x times 1 over 2x. Right? Instead of dividing by 2x, we can multiply by its reciprocal. But we still want to split things up a little bit before we start taking the limits of things and fixing things. So we have sine of x times 1 over cosine of x times 1 over 2x. Now remember, 1 over cosine, that's okay if we're doing the limit as x approaches 0, because cosine of 0 is 1. So we don't have to do anything special when we have a cosine, just a plain old cosine, either on top or bottom. It's when we have that sine of x, because sine of 0 is 0, and then we've got this is going to be 0. So to take care of that, we need an x in the bottom here. So we're going to multiply the bottom by x and the top by x. We don't need it here. We can use it here, though, to cancel this x out. So I'm going to put the x on top right here, paired up with the 2x. Then we can find the limit of each part. Here we know the x's cancel out. And the limit as x approaches 0 of sine of x over x is 1. The limit of this one is 1 because 1 over cosine of 1 is just 1. And then here we're left with 1/2. So our overall limit here is 1/2.